I'm going to move on to the third part, which is how we can send MQTT to AWS IoT. Okay, again, you have to get an AWS account and sign up for an AWS IoT resource to get this started. Okay, so first thing that AWS IoT actually kind of different from the other two, the Azure and IBM, is that itself, the AWS IoT core itself, could function as an MQTT message broker, so like an MQTT server. Okay, so if you're, you can do regular subscription and regular publishing and to exchange data between different devices. So just up to some, or just subject to some restrictions like the QoS or some reserved topics. But otherwise, it should function more or less like an MQTT server. How do you do it though? That's what I'm covering right now. Okay. So if you want to connect to AWS IoT, here this is a table with information on how you set up your connection. So the only thing that's interesting here is the domain name. So domain name can be found in the IoT Hub, and we will go to that very shortly. And you realize that there is no username and password here. It's because at AWS IoT they use different kind of security than others. So it uses the X509 authentication method. So it uses the certificate for authentication. So you have to have an X509 compliant certificate in order to communicate with AWS server. And you have to have policies predefined that determines whether a particular certificate holder are allowed or denied certain functions. So now let's move to AWS IoT. So this is the interface of the AWS IoT. And I said, where you connect to is located in settings and custom endpoint, where you'll find your connection, basically your domain, your own domain name for connecting to IoT, your AWS IoT. But as I said, to connect to the AWS IoT, you don't use username and password. You have to use a certificate with certain policies attached to it. Okay. So in order to get the certificate for our HMI, we can generate it in AWS IoT. And here's how. You go to secure under certificates, where you can do creation of certificate. And if you just follow the steps to create your certificate, you'll come to this page where you have generated a new certificate with its X509 certificate file. Okay, so you have to download all of these. So your certificate for this thing, your public key, your private key, and a root CA here. Okay, so this guy. So you have to download this guy as well. Okay. And then you hit activate to activate this. Okay. And then you have to attach your policies. Okay, but I haven't had a policy defined yet. So let me go back and create a new policy. So the second selection is policies. And you have to create a new policy too. And you give it a name, so we'll use today's date. It's a policy. And for the action, I'll write this IoT with a star means all IoT operations. And the resource also a star just for ease management. And I use allow for this policy. So this policy means that I'm allowing all IoT operations, so IoT like publishing, subscribing, etc. I hit create. So I have a new policy. It's called Web 0919. Okay. So I go to the certificate, and then I can find. So I can find this. The last one was the one I just created. I can do an attach policy and attach it to the one I created. And now I'm done with creating a certificate and attaching it to a policy. Okay. So I did this. So now back to the HMI setup. So in your in the eViewer Pro, you have to set up the server verification and client verification for connecting to AWS. So I will show you right here how this is done. Okay. Okay, so in your MQTT server settings, we have what we talked about before with the domain name from the custom point. And here what's different is that not only do you have to enable the TLS SSL, you have to import your certificates for server and client verification. And for server verification, so I have listed in my slides which one you should import. So for the server, you import the root CA certificate. So for the client one, we import a client certificate and a private key. Okay. So you should have also download a public key, but actually it's not being used right here. Okay. So having set up this, we can do connection. Okay, and you can see this is mine. Like I said, we can the AWS IoT function as a regular broker, so I can use any topic I like. So IoT equals /data is my topic today. And in AWS IoT, you can use this function to see your MQTT connection. Okay. So here under test, I can subscribe to a topic or publish to a topic. And since I'm going to publish from my HMI, my simulated HMI, so if I want to demonstrate to you, then I should subscribe to this topic, IoT /AWS /data. So let me just do a subscription right here. So IoT /AWS /data. Okay. So then you subscribe. and can just publish and see. So here now I'm using the AWS core, IoT core as an MQTT server. So I can send and receive data through MQTT, through more or less the regular MQTT with AWS IoT on the back as a service. Okay. On that. So the last, the device shadow service of the AWS IoT. Okay, first a little bit about the terminology of the AWS IoT thing. So kind of unlike the previous two, device that's connected to AWS IoT are not just called device. They're called. So in the AWS IoT core platform, you will have to, just like before, you create a thing in it so that the platform knows that there's something that's going to connect to it. Okay, so here's where you connect, and it's recommended that you attach a certificate to your thing when you do this exercise. Okay, so let me just go to that. Okay, so here's our Amazon's IoT platform, and so under Manage and Things, you see a list of your things. So if you don't have any, then you won't see any here. But here's where you can create your thing. You hit Create, and if we want to do one at a time, we hit Create a single thing. So you can give it a name, any name, and a type. And you can leave anything else and just hit Next. So here it asks if you want to add a certificate for your thing. Okay. Well, you can create a certificate here, or you can skip this step because we actually did create a certificate already. So what we can do is we can go back to certificate page, secure and certificates, and let's find the certificate we want to use. So take this one for example, and we can again attach. Before we attach it to a policy, now we can attach it to a thing. So I can attach it to the thing I created. What's the name? And to attach. Okay. So these are the preliminary steps that you should do when you work with Device Shadow and thing. Okay. Continue. Now the device shadow. So what's the device shadow though? So basically, device shadow is it's basically a document inside the IoT platform. So in this shadow, it stores basically the current state of your device or your thing. So you will allow others to retrieve the current state of this device. The shadow document is a JSON document and looks kind of like this. Okay, so you see that it basically is a description of its very different kinds of states. But there are two main components of this shadow document. So one you see is a desired component. The other is a reported component. So how are these different? So basically, for a shadow, there are two kinds of states, the reported states and the desired. So the definition of the reported states is this is where things write to report their new state. And if you have an application, the application will read this part to know the state of the thing. So kind of like monitoring the state of this thing. You can see this following image. So if, for example, on the left side, my server is basically connected to a thermometer. It's a thing, the temperature reading. So when it has a new reading, 23 degrees, okay, basically you'll have to report to the AWS IoT. So it goes from this SPR or the sensor to the AWS. Whereas on the other side, my screen application, the monitor station, it's reading the reported data. So the data will go from the reported of the AWS to the application. Okay, so you could take note of these kind of direction of flow of the data, because that's where our settings in HMI will matter. Okay, the other state is the desired state. So it's basically opposite of the reported state. So for desired state, it's where application can write to in order to update the state of the thing. So, and without having to actually directly connecting to the thing. So our picture will look opposite. So here we start on the right. So our application, it tries to turns the light off. So on the other side, we have a thing, a light. Okay, and the application tries to turn off. So it sends data to the AWS IoT to the desired part and saying, I want the light off. Okay. And on the other side, the light itself or the CN of the SPR connected to it, it takes the desired data for the AWS IoT and recognize that it's a command to turn the light off. Okay, so when it happens, it will turn the light off. It should turn the light off. And this is how the desired state works. So basically, combining desired reported behavior, we can basically achieve remote monitor and control through this AWS IoT platform. And also, don't forget that this is just part of interfacing with the AWS IoT. There's a lot of other services behind the AWS IoT, like the database or Lambda functions or other AI computation analysis, etc. If you want to use this AWS IoT Thing Shadow with our HMI, here's how you would do your setting. It's very similar to when you're not using a shadow, when you're just using it as MQTT broker. Okay. The main difference is that the cloud service, now there's a dedicated option, which is the AWS IoT. Okay. You choose the AWS IoT, and the rest are the same. Domain name, the port, client ID, system topics, or all the certificates imports are exactly the same. And it's regardless of whether you want to send reported data or you want to send desired messages. Okay, they're the same. However, when you choose the AWS IoT, there won't be any options for sending topics because the topics is irrelevant now. Okay, so instead you're not controlling a thing, or you are actually the thing, or you are controlling the other thing, depending on whether your role is a device or an application. So before we dive further, let's go to our okay. Okay, in ePro, the MQTT, just double check our server settings. Okay, so oh, I think I opened the wrong file. I need to open the file. Okay. Okay, let's look at the settings first. You see, only the cloud service is AWS IoT, but the rest are pretty much the same as before. The domain name and TLS settings, basically, you can use this. Okay, so as long as you have attached it to the thing you're going to use, then basically the same certificates will be fine. Okay. All right. So on the bottom, you see the interface is completely different now. There's no more publishing topic and starting topic. Now it's just thing. Okay, so you can add a number of things that you want to use. Here, we're gonna deal with this thing called webinar thing. So this thing will be the same thing which you define in AWS. So it should be so this thing name will be the one on AWS. So this cannot be any name. So it basically has to match the actual thing you want to control or remove on AWS IoT. Okay, so the most interesting or the most, I guess, the complicated part is the address part. So here is what object or what addresses do you want to report to, on the control for your HMI. Okay. Okay. So you have each of them will be a state in a shadow document. So basically for this thing, if I set it like I'll have these 4 states in my shadow document. It could be reported or it could be in my set. Okay. So for each one. And then okay, you start with 2 and 4. And actually I'll start with the one with 4. With 4 types you see 4 types of settings. So 2 statuses. Okay. And 2 of them relates to the reported type, and 2 are the desired type. And this is actually the advanced mode. But we actually use the advanced mode because I believe that advanced mode gives you more control and actually lets you more easily understand what this thing and how the desired and reported data works. Now let's go back to slides a little bit. So basically in advanced mode, there are 4 data flow, but we can still categorize it to two types. Basically, first one is depends on your role. So if your role is a device, so if you are a device, then basically you are reporting your data to the shadow. So it goes from you, okay, the first one. Or if you're a device, someone try to control you, so they will get the desired part of the thing. And when you see the desired part is changed, then you will update your data accordingly. So if your device type is from desired to you. But the other role for an application, okay, so basically the one who's controlling or who's actually monitoring. So if you're an application, and the first thing is if the device has new data, you'll report AWS IoT, and AWS IoT will report you. So your data is updated by the shadow. Okay, so you have reported to device. And on the other hand, if you want to do a control, of course, the data will go from you to the desired part of the AWS IoT. So basically, if you remember these four characteristics, then when you try to set up in EB Pro, you know exactly which one you use, depending on what's the role of this particular HMI. What's its role in your complete, basically your, in your system. Okay, so a more concrete example. So just before, okay, when my thermometer, the thing is a device on the left, trying to report its temperature. So we're on using the advanced mode, but here I'll choose from device to AWS IoT reporting. Okay, so I'll take this one only, and I'll use an address with the data that I have. Okay, so maybe from some temperature thermocouple, something. Okay. But the application on the right, its role is an application. So it takes from data from the report to itself. So you will take the second one. So AWS IoT reported to device address. So you'll pick a device address, maybe like the local address 100, and you will show local address 100 on its screen to monitor this the thing far away. Okay. Okay, the other one, very, very similar. We talked about this before already. Again, we also start from the right. Okay, so when application try to control the desire, data go from device address itself to AWS IoT desire. And if the thing is to be controlled, so the data should go from the desire to its own device address. It's the same thing, just okay. So we look at the demo first, very quickly. Okay, so this one and my word two, my bit two. Okay, so the ones on the left will be the one being reported. The one on the right will take the desire. And we'll see how this integrates or it works with AWS IoT Shadow. So let's go to the shadow part of our thing. It's under the shadow of my particular thing. So this particular thing I work with is the web thing. So this one. Okay. So let's first work with the report. When I have new report, okay, whenever I have new data up, I report up. AWS IoT receive it and update the shadow. Okay. And if any other thing is monitoring this reported part of the document, then it will update its own data. Then through this way, we basically transmit data to far away. Okay. Similar. Okay. When I started my CMC simulation, it already take the desired state from the shadow document. So it started as 999 already. But just for illustration purpose, just change this value of one of the desired. I change it to 666, and the bit state to true, and just pay attention to what my HMI's bits. Okay, so I'm basically forcing a save to the shadow document. So once saved, basically it's like someone saying they want the desire to be 666 and true. So the shadow state changed in AWS, and our HMI, basically now this is now as an application. Sorry, this should be as a device. As a device, it finds out that someone is trying to change the desire to 666, and it knows it should change accordingly. It's just like someone trying to set the thermometer to, set the temperature to maybe 100 degrees, 20. Okay, then here I'll change my temperature setting to 20. Okay. This is a short demonstration. So this should be clear by now how this device shows. So this can be really expanded to basically make a full-blown application, and we actually have done that already, and I'll show you very quickly in my example that I have done. Okay, so there's one thing though, is that why did I talk about the advanced mode instead of a simple mode? So isn't simple mode always easier? Why are we, just going for the advanced mode? Okay. Well, the simple mode has its own advantage, though. So, well, first of all, simple mode basically will narrow the 4 options to 2. So when you go to the simple mode of your Pro, oops, make it the wrong one again. Okay. Okay. So when you're at the simple mode, basically you only have 2. So the first one is status, and it goes from the device address to AWS IoT reported. Okay, so this is the same as one of the advanced modes. So basically the same as the first one of the events. So there's no problem, no problem with that. Okay. But then the other of the simple mode is a setting, and it's from PLC address to AWS IoT desire, and it's a bidirectional arrow. So what does that mean? Do we have that though? Well, just as we trying to develop the tool, that's what we realized is a lot of time with our, it's not simply setting. So if we are using like our set word object or set bit object or like a number display that cannot be written, then it works like what we've been talking about. Okay, but a lot of times for HMI users, we use a lot of things or objects that do both the reading and writing of data. And we write the same piece of data on the same object. Okay. So, and this could cause a problem in this kind of in this type of device shadow, this kind of against the data flow. I mean, there could be problem because when you write something, then because we haven't detected that the hash data has changed, and so we don't know the data has changed. So our local device cannot really reflect that, or we might actually overwrite what we already the data we already wrote. So this could cause a very, very strange behavior of our HMI's objects, especially like I said, like numeric inputs or like toggle switches, which use both read and write of the same address on the same object. Okay, so instead, if we have a local and a remote HMI, both of them are accessing the same address, then we should use this one. So we should actually use this one. So device address and desired, and with a double arrow. When your HMI can monitor, but the actual HMI, which controls when it changes, it has to reflect it to the one far away. So let's look at the example. So let's see on the right. So so both our HMIs are, they're connecting through the AWS IoT with the thing. Okay. And they have, so on the right is the one far away, and it's we wanted to switch a light on. Okay, but we're usually we have a light switch. We use a toggle switch. The toggle switch will display an on and off status, whereas it also lets you to, you to toggle change. Okay, so on the first step, your app to send the on message to the AWS IoT as desired. Okay, so switch it on. Desire will tell the actual thing that, okay, you have to turn on because it's being desired by someone. App on the right, it actually never knows if the actual light has been turned on because there's no feedback. I just try to turn on I make a comment to ask it to I actually don't know if it's on already. So it actually come back to the off state. And that's where we try to solve the problem. So if we have it as a desired, then when the light actually goes on at the so it will report back desire and it will revert to the HMI A, telling it it's already on. So the switch or the toggle switch will eventually come on, and this would make more sense when we have this kind of situation. So we realized that this situation could be common in many people's usage for HMI. So we decided we put this under the simple mode of the thing, shadow. Okay. So finally, like I promised before, I already made a showroom demo for ourselves with the AWS IoT Device Shadow property. So it goes in this kind of architecture. So we utilize the AWS IoT, and let's look at on the right first. So I have made a couple of Arduino based sensors to take in some environmental data like temperature, humidity, etc. Okay, and it's connected to each is connected to an CMT server. Okay, so themselves they are local monitor module. Okay, but on this MQTT AWS IoT, they're also a thing. They're also each individually designated as a thing on AWS IoT. Okay, so I dispatched them to many corners of the world. There's in China, in the States, in Korea, and one in our office in Taipei. Whereas on the other side, also in Taipei, basically in our office, we have in CMT 3151. So this one works as an IoT monitor dashboard. So this, through the MQTT's AWS IoT, we control and monitor all of them, okay, through the AWS IoT. And without, the key point is that it goes without the use of other remote monitor technologies like the VNCs or EXAXis, etc. So this could all have been done with AWS IoT. Okay. So this is a sample of how I would have set up each of my CMT SBR. Okay, so this I already explained earlier how we should do our setup for this. Okay, so this is what the real Arduino and SBR look like. I believe this one is in China. Finally, a little note about the data encryption when you're using MQTT to any of the cloud services. Okay, so we know that for the encryptions, we use the SSL TOS encryption in MQTT. But actually, there is a version difference that you should be aware of. So for Azure recommended that you use TLS 1.2 or basically 1.2 recommended. Whereas for IBM Cloud in AWS IoT, TLS 1.2 is required. Okay, so this could cause slight problem for some of our users. Okay, the thing is that the TLS 1.2 may not be supported in some of the older models, basically the non-CMT models. The one with older OS versions might not have TLS 1.2 support. So, first, if you use a CMT model for any of the applications we discussed today, then you should be fine. But if you're using like one of the IE, XE, MTV, or EMT series, then you should first, if you find yourself not being able to connect to one of the cloud servers above, especially the IBM or the AWS, then perhaps you should check first what's your OS version and maybe consult one of our FAE if that version has TLS 1.2 supported. And if not, you might have to upgrade it to a support version. And yes. Okay, so yeah, just check it. And if it doesn't work, then pop up this question now. About what we have been doing today. So today we've been focusing on how we could, as an HMI, how we take the PLC's data, we send it through the MQTT to an IoT hub. Okay. And this IoT hub, whether it's AWS, it's Azure, or IBM, we already have done it. We can set it up to the hub. And then one can really utilize what's available in their cloud service platforms to use the information, to send it to UI, to AI, to get the best of all this data we collected from the device. And that's the true meaning of what we try to accomplish with the IoT. So I'm just gonna leave it as it here. And I have some more information that's in the slides you have. Unfortunately, we don't have time to cover them all, but if you have questions or you want more details, you can always send us an email asking about what it's about. Okay, so thank you for attention.